Come and thank you all for standing by. At this time, all participants will be on the listen-only mode until the question and answer session for today's conference. I would also like to inform all participants that today's conference is being recorded. If you have any objection, you may disconnect at this time. I would now like to turn today's conference over to Mr. Dave Steeds. Thank you, sir. You may begin.
Thanks, and hi, everyone, and welcome to today's media update on the low-density supersonic decelerator project from Kauai, Hawaii. This is Dave Steeds. I'm with NASA's Office of Communications here at headquarters in Washington. We're going to hear from our program manager and our principal investigator for LDSD, and then we'll take questions from reporters. As mentioned, the call is being recorded, and it will be available for replay by dialing 1-800-839-1195. And I'll give that number out again at the end of the call. If you have questions for our two participants, please hit *1 and you'll be added to the Q&A queue during the call. With that, I'll turn it over to our two participants. We've got calling in from PMRF, the Pacific Missile Range Facility, the U.S. Navy's Pacific Missile Range Facility in Kauai, Dr. Mark Adler, who is the LDSD project manager from NASA's Jet Propulsion Lab in Pasadena, California, and Ian Clark, the LDSD principal investigator from NASA's JPL. Mark?
Good morning, Dave. So just to give a quick summary of where we are, we came out here, LDSD came out here for a test flight of our balloon-launched supersonic vehicle to test new Mars landing technologies. We had 6 potential launch days from June 3rd through June 14th. The last of those days is actually 2 days from now on Saturday. All of our vehicles, our systems, our teams were ready. We were prepared for all of the launch days. We were ready to go. The only thing that held us up is that none of the launch days had or will have acceptable weather conditions. In particular, we needed the mid-level winds, the winds between about 15,000 and 60,000 feet, to take us away from the islands in order for the flight to be safe. We have to make sure that the balloon is carried away from the island. The balloon cannot be steered. The balloon only goes where the wind goes. We have very good predictions of where the wind is going the day before. We use those predictions to decide whether or not to launch. In fact, even a couple days before, we can tell which way the winds will blow. And unfortunately, over the past 2 weeks we've had for this launch, we have not had the proper conditions, the proper wind conditions to carry the balloon in the direction that it needs to go. We did conduct very detailed wind and weather studies in the last 2 summers in the same time period that we're trying to launch now in 2012 and 2013. We also looked at other data from 2008 and 2009, and all of those years were consistent with each other in predicting good conditions and a good probability of launch for our current 2-week launch period. Unfortunately, for some reason this year, the weather was quite different. In the Northern Hemisphere, there was a longer winter, later arrival of summer. It caused the weather patterns here at Kauai to be different than it was in previous years, and as a result, we have been checking the weather every day and looking for the proper conditions and not been getting them. We still have a great vehicle to fly. We have great support here from the Pacific Missile Range Facility on Kauai. We're ready to go. We're not giving up. We're looking at other opportunities potentially for later this month, so we're looking to see what our options are so that we can still try and fly this test vehicle out of Kauai this year. I'll turn it over to Ian.
Thank you, Mark. I just want to underscore, the technologies that we have, the importance of developing these, all that is still in play. There are a lot of folks who came focused, ready to do their job. We've spent a couple of years now developing these technologies, designing, fabricating, testing, developing this test vehicle that will enable us to mature these technologies for eventual use on Mars. But I'm reminded that the journey to Mars is it's longer than the 8 months it takes to go from Earth to Mars in a spacecraft. It's the years preceding it in terms of development, testing, retesting, fabrication, and all the launch operations that go into it. There's years of hard work. A little delay like this associated with the weather is hardly even a hiccup along that timeline. And that timeline is even longer when you start thinking about humans on Mars, in which case it could be decades of development associated with it. So the team is very focused to take this in great stride. We're still very enthusiastic. We're still very optimistic about the opportunities that we think we'll have in front of us to do this test.
Okay, thank you, Mark and Ian. Again, if reporters on the line have questions, please hit *1, and we'll add you to the Q&A Q. We'll take our first question from Peter King.
Great. Thank you, David. Peter King, CBS Radio News, and you're hearing me all right?
Yep.
Great. I don't know who should get this question, so we'll say toss-up, and I actually have a couple here if that's okay. How long do you plan to stay out there until the weather conditions are right, or how long can you stay out there? And along with that, is there a sense of urgency to get this done in that kind of time frame?
So we are now looking at our options to see what the range can accommodate here at PMRF. They have many other customers here, and also what our teams can accommodate. Our teams have other, for example, our balloon team has other missions that they need to fly. And so we're considering right now the possibility of not necessarily staying, but going home and coming back a little bit towards the end of the month, where we might have some opportunities to try and fly again. We're still working out the details of that.
Roger that.
The urgency.
And who is speaking?
I'm sorry, this is Mark Adler.
Okay, I'm sorry. Thanks. Go ahead.
And so in terms of urgency, we would very much like to get this flight off this year in terms of the schedule of the project and trying to maintain the total cost of the project. We really need to get this flight off this year. If not, it would have to be delayed till next year. The only opportunities we have, based on the previous wind studies of years of months that would work, is the June, July, and August time frame. So if we don't make it off in this summer, then we have to delay this flight until next year.
And Mark, a follow-up would be, I'm curious about the cost. I don't know what the cost of this mission is to begin with, so if you've got that, that'd be great, but I'm wondering, what the delays do to your budget, and do you find yourself with a blown budget and in trouble money-wise?
So the total project cost is approximately $200 million from end to end. We started in 2010. This project goes through the end of 2015. In terms of the amount of money, also as Ian said, it's a relatively small amount compared to the total cost of the project that we've currently spent here in a couple of weeks at PMRF. It's a relatively small cost that we would have to try and create another opportunity later this month. So I don't think that's a huge thing. It will be something that NASA is interested in trying to accommodate to make sure that we get off, because they are very interested also in us conducting this mission this year.
Thank you.
Okay, thank you, Peter. Next up, we'll take a question from Alan Boyle of NBC.
Peter pretty much asked the questions that I was aiming to ask. So I assume that you'll keep the vehicle in Hawaii at least for the next few weeks. And could you tell me how much that vehicle weighs?
Yes, we do plan to keep the vehicle here at PMRF. We'll store the vehicle here. And also a lot of other equipment that we have here, the balloon equipment, the balloon tower, all of the launch support equipment that we have will stay at PMRF. We have agreement from PMRF to leave it in the facilities that they're in. And what was your second question?
How much the vehicle weighs?
So that's a 7,000-pound vehicle, actually 6,800 pounds. It hangs on a balloon, which has another about 1,000 pounds of equipment hanging from the balloon. So the total launch mass is about 8,000 pounds that is carried to 120,000 feet.
Thank you.
Okay, again, if you have any questions for Mark or Ian, please hit *1, and you'll be added to the Q&A queue. We'll now take a question from Bill Harwood of CBS.
Yeah, thanks, guys. And I think you guys went over this in the initial press briefing we had, but just for the record, why is it that you couldn't launch this someplace else? I mean, rather, Guam, New Mexico. I mean, just what are the reasons why it needs to go from Hawaii? Thanks.
Sure. Yeah, again, this is Mark Adler. We looked at actually many sites around the planet. We looked at many launch sites and other kinds of places where we could try and conduct the mission, places where we have or have not conducted balloon flights before. We had to find particular conditions where the winds would be favorable to launching a balloon near the surface. We couldn't have very high winds near the ground so that the balloon would be able to be launched and not be damaged by the wind. We had to also have conditions where the higher level winds would take the balloon away from populated areas. We had to have good visibility for the launch. We had to have several other conditions to make sure that the mission could be conducted safely and have the proper equipment at the site to be able to conduct telemetry and other things for the mission. So when we looked at all these sites, we found that really there were only about two places on the planet where we could try and do this. One was in Woomera in Australia. The other was here on the west end of Kauai. The reason this site in Kauai is special is that, first off, it has the proper conditions of the surface. There is a large ridge behind the base that protects it from the prevailing winds from the east, and that ridge allows us to launch the balloon safely. However, once it clears the ridge, there are strong prevailing winds at higher altitudes that normally take the balloon out over the ocean towards the west, where we actually conduct the mission out over the water.
Okay. Again, if you have any other questions for our Mark or Ian, please hit *1 and we'll add you to the queue. Next, we'll hear from Robert Perlman of Collect Space. Robert?
Hi, thanks. Can you just say what limited the range this time in terms of specifically why the date ends on Saturday? Given that you're talking about coming back at the end of the month, is there a specific reason you have to be optimistic for better winds at that point?
I guess you're asking if there's a reason why we might be optimistic about better winds?
Yes.
Yeah. So let's see. So I'm sorry, I forgot the first question.
The first is, why was Saturday the last day available on the range? Is there something bordering up to it?
So we planned this out sometime in advance, and we had to request from the range certain days that we could do the mission. As I mentioned, the range has many other customers, and especially this year, and in fact in all of the even years, the range has a very, very large activity in July, and there are many other activities around it. And so we were somewhat constrained in how many weeks we could get on the range. We were able to get these first 2 weeks of June for our launch days, and we believe, based on our previous studies, that would give us sufficient probability of being able to launch in those 2 weeks. But that was basically what we could get from the range. Now, we have managed to negotiate with the range the possibility of days later in the month, which is what we're going to try and work out the logistics for, to see if we can actually attempt some launches in a couple more days towards the end of the month. And as far as I'm sorry, what was the second question?
The optimism.
So why do we think it might be better at the end of the month? We have seen the weather patterns change as we've been watching them, and it's been actually tantalizingly close to having acceptable launches. We had a couple of days where we were so close that we actually decided to proceed with the launch preparations and check the weather again 12 hours before, and found that, in fact, it was continuing to go in a bad direction instead of a good direction. So we were extremely close to having good days, but they just skirted areas where they weren't allowed to skirt, and so we had to not conduct the launches on those days. So we see there's good potential simply in the weather variations we've already seen that there could be a good launch day. The second thing is we are seeing in the long-term forecasts, which aren't very reliable at this point, but we are seeing some significant changes in the weather patterns towards the end of the month that could indicate that we would have some good days.
Okay. We'll take one last opportunity to encourage reporters to ask questions. If you have any questions, hit *1. I'll also mention that at 2 p.m. today, we're going to be having a briefing on NASA's Orbiting Carbon Observatory 2 mission. OCO2 is an Earth science mission also led by NASA's JPL that'll be launching next month, and that briefing will be carried live on NASA TV as well as streamed over this same audio line. We'll take one final question from Bill Harwood of CBS News. Bill?
Yeah, just a human interest thing. I mean, you guys have obviously had your hopes pinned on this for quite a while, and it must be disappointing to get down here to the crunch and have the weather not cooperate. I'm just wondering what your personal thoughts are here, all technical issues aside. Thanks.
The team has been working on this mission. This is Ian Clark. The team's been working on this mission for several years, and during that time we've been incredibly focused, and we came to PMRF, and we came to Hawaii to do our job, and the weather unfortunately did not behave with us and allow us to do that. But I'd say the mood of the team is still very focused, and we still have this job that we want to accomplish, and we're very optimistic. We know that we think that there are some opportunities that'll be in the near term, and we certainly have more tests like this that we're planning for next year here in Hawaii. There's also tests part of this project that are ongoing in other locations that everybody's gearing up and executing. We have more parachute testing to conduct at the China Lake Naval Air Weapons Station. We have more SIA testing conduct there as well. We were doing some subscale parachute testing at wind tunnels at NASA Langley. there's really just a lot of activity, going on, and so everybody's still very focused about the end goals of maturing these technologies.
Yeah, and this is Mark Adler. The bottom line is that we have faced many hurdles in getting to this point. We're developing new technologies. We're developing new test vehicles that have never been built before, and this is just one more hurdle along that path. And so this is not something that the team is suddenly facing something they haven't faced before. We have an issue. We're going to deal with it, and we're going to try and fly this thing this year.
Thanks a lot.
Okay, thank you, Mark and Ian. Again, this call will be available for replay by dialing 800-839-1195. And you can learn more about NASA's LDSD program and our investments in space technology by visiting www.nasa.gov/spacetech.